In this demonstration, I'm going to show how to use Nexus Dashboard to quickly identify, isolate, and resolve a network issue impacting a critical business service. We'll walk through how to correlate user-reported symptoms with network insights, pinpoint the failure point, and determine root cause using built-in analytics and assurance capabilities. In this scenario, a financial services organization is experiencing an outage, with users reporting they cannot access critical services starting around 10:30 a.m. I'll use Nexus Dashboard to investigate and resolve this issue. I'll begin by navigating to Traffic Analytics to quickly assess overall service health. Looking at the key metrics, latency and congestion are both healthy, but drops are flagged with a warning, indicating packets are not reaching their destination. As I scroll down into the service categories, I can see that the financial services application is one of the impacted services. Drilling into it, I can confirm the degradation is driven specifically by drops, which gives a clear starting point for further investigation. Filtering to the affected endpoint and client, I can see a single service endpoint and impacted client. The timeline shows degradation beginning around 10:20 a.m., which aligns with when the issue was reported. The affected users are external and policy-related drops are visible. Next, I'll initiate a flow collection for the affected client to determine exactly where traffic is failing. I'll scope this to a short duration, just a few minutes, to quickly capture relevant flow data while the issue is active. In parallel, I'll capture a fabric snapshot using assurance. This allows me to preserve the current degraded state of the network, so it can be compared against an earlier snapshot from when the network was healthy. Together, this gives both a real-time view of where traffic is dropping and a before and after comparison to understand what has changed. The assurance job has completed, and the latest snapshot is now available for analysis. I'll use delta analysis to compare this newly collected snapshot, captured during the issue, with an earlier snapshot from when the network was healthy. This allows me to quickly identify any differences in state, anomalies, or configuration that could be contributing to the problem. While that delta analysis is running, I'll also continue monitoring traffic analytics and the flow collection results. From the flow analysis, I can clearly see that traffic is being dropped at BLR2 Leaf 3. This pinpoints exactly where in the network the failure is occurring. Now I'll check routing to validate reachability. The route associated with the affected client prefix is no longer present. Looking at route history, I can see that the prefix and its next hop, 3703, were removed around 10:29 a.m., which matches the onset of the issue. Since this route was learned via BGP, next, I'll check for anomalies. I can see that BGP sessions are down on both Leaf 3 and Leaf 4, connected to the same peer, 3703. That indicates a loss of routing adjacency. Now that delta analysis has completed, I can see new anomalies in the current snapshot that were not present earlier, including the BGP peer failure and the impacted service endpoint. I'll filter to see only what's different. Here I can clearly see that a BGP peer connection down event appears in the current snapshot, but this was not present earlier. This confirms that the fault was introduced after the baseline snapshot and is tied to a BGP issue. Next, I'll look at the policy delta to understand what caused this. The BGP neighbor configuration has changed. The remote AS value was previously 100 and is now set to 101 for neighbor 3703. I can also see this change applied across both Leaf 3 and Leaf 4. This incorrect AS value caused the BGP sessions to fail, which removed the route and ultimately disrupted service connectivity. At this point, I can clearly see that the BGP configuration change caused the route to be removed, which broke reachability and impacted the financial services application. I'll quickly verify this on the device, confirming that the BGP session is down and the remote AS configuration is incorrect for neighbor 3703. Now I'll correct the BGP configuration. Once the fix is applied, the BGP sessions begin to recover, and the route is restored with the correct next hop. As traffic resumes, I can see in traffic analytics that drops begin to clear, and the service health score trends back to normal. This confirms that connectivity has been fully restored. With that, the financial services application is fully restored. This troubleshooting workflow demonstrates how Nexus Dashboard combines capabilities such as traffic analytics, flow collection, routing table telemetry, delta analysis, anomaly detection, and real-time operational visibility to accelerate troubleshooting across the fabric. By bringing these insights together within a single integrated workflow, operators can rapidly correlate symptoms, isolate faults with precision, and identify root causes much faster.